Another thing we haven't really seriously talked about is the population size. So in population genetics and molecular evolution, a lot of times we are talking about selection, but also we want to understand what's the population size or how the population size influence the evolution. So the population size, usually if we look at the individual, a group of individual, and that's like the counting method, we can count there are probably say 24 individuals, 26 individuals in the population. So that's the counting method. But when we concern about effective population size, and that's the one we want to ask, how many individuals in this pool are contributing to next generation. So how many of us are contributing to the gene pool for the next generation? And that's what we call the effective population size. So the total population size and the effective population size could be very different in certain population. So that's what we are concerning. And sometimes in the paper, based on the sequence analysis, they will try to infer the historical population size or the changes in the population size back to historical time. The only thing I want to emphasize is the census population size might be very different from the actual population size which contribute to the gene pool for the next generation. So that's the only thing we want to emphasize here. As I mentioned last time, it's very important to understand the effective population size. That's why a lot of people using population genetics approach to estimate the historical population size. So that's something you might want to keep in mind when you read the literature. So this is a summary about the population size. In general, the effective population size is much smaller than the population size you can count from the nature. Then in a population which usually have overlapping generations, it's very hard to calculate the population size or to calculate the effective population size. And also, in a lot of species, we have equal number of male and females, but that's not a general rule. So for some species like parasitic wasps, they have much more females than males in any given reproductive time. So in that case, we have to recalculate the effective population size based on the sex ratio in a given group. So this is like all listed in your textbook. Then also, as I mentioned, there are fluctuations in the population size. And in general, the smaller population size will affect more to the overall genetic structure in the population. So this is the summary. And this is just to show you the formulas about like how we recalculate or estimate the effective population size based on sex ratio, so that's the formula on the top, or based on the the population size in different generations is in the bottom. So as the formula showing here, you can see the point I just made in the previous slide. When the population size is fluctuating over several generations, and the smaller population, the smallest population size, affect the overall genetic architecture of the population the most. So that's like showing in this formula. I think it will be much clearer if you look at the formula here.